Welcome to Math with Rashad and Jerry. Today we will be teaching you about periodic functions.
A periodic function is a function that repeats itself over an interval called a period. The most common periodic function is the sine wave. The amplitude of a wave is defined as the distance between the axis or center of the wave to the top of the wave. This sine wave has an amplitude of 5. Another characteristic of a wave is its period. To find the period of a wave, you find the distance between two corresponding points on the wave. This wave has a period of 2 pi. The last thing about a wave is its frequency. The frequency of a wave is 1 over the period. This wave's frequency is 1 over 2 pi.
While the most common example of a periodic function is a sine or cosine wave, there are also other functions which may not have an equation but have a repeating pattern and also qualify as a periodic function because they have amplitudes, periods, phase shifts, and axis equations.
When you are given an equation for a sine or cosine wave, you can find the characteristics of the wave without graphing it using these equations. The amplitude is the absolute value of A. The period is 2 pi over B. The phase shift is C, and the equation of the axis is D.
Write the equation of the sine wave with amplitude 3, period 12, phase shift 1, and axis of y equals 60. The standard equation for a periodic function is y equals a sine b in parentheses x minus c plus d. The amplitude was 3, so we know a equals 3. To solve for b, we can have the period of 12, since there are 12 months in a year, as equal to 2 pi over b. Solving for this, we get b equals pi over 6. C equals 1 because there's a phase shift of 1, and the axis is y equals 60, so d equals 60. Our equation is y equals 3 sine pi over 6 in parentheses x minus 1 plus 60.
So we have a month and temperature table here with average temperatures for each month, and we have to write a sinusoidal function to model the data. To find the amplitude, you would take the highest degree minus the lowest degree over 2 to get 25. And to find the axis, you would take the average of the temperatures to get 65. And the period is 12 months, so you make it equal to 2 pi over b. And solving gives you b equals pi over 6. So plugging in all of our values into the equation, we get f of x equals 25 sine pi over 6 quantity x minus c plus 65.
Now, using the lowest point, we can solve for the only remaining variable c. So our equation f of x equals 25 sine pi over 6 in parentheses x minus c plus 65. We plug in our x value of 1 and our y value of 40 and solve. We get an equation of negative 1 equals sine pi over 6 parentheses 1 minus c. Taking the inverse sine of both sides, we get the inverse sine of negative 1 equals pi over 6 in parentheses 1 minus c.
After taking the inverse sine, so the inverse sine of negative 1 is 270 degrees, which is 3 pi over 2 in radians. And multiplying both sides by 6 over pi, we get 9 equals 1 minus c, and we get that c equals negative 8. So plugging in all these values back into our original equation, our final equation is f of x equals 25 sine pi over 6 x plus 8 plus 65. Thank you for watching.
Thank you. Yeah.